Call me because my name's Aaron. Big A.
The big A.
But I'm not very big, so.
Much tall.
No, I'm tall.
You're tall.
Kind of scrawny.
All right, so here, let's just, what dimensions are being used here
All right.
in this experiment, or in this measurement?
We are measuring mass.
Kilogram is mass, so that's the dimension.
Yes.
All right, now, miles per hour, that's kind of like two different
Yeah, that's a
things.
length
So miles would be length.
over a time.
Length over time, yeah. All right, grams is
That's a mass.
mass, yeah, and then moles
That's a quantity.
per amount.
Amount, yeah.
Yeah, or quantity, same thing. Really.
Yeah.
And then grams per milliliter.
That's a mass
That'd be
per
a mass per volume. Or, what else could you say about
We
it?
can call that density. Density
Yeah,
is
well,
grams per milliliter.
or you could also call that mass per distance
Cubed.
cubed.
Because milliliter is the same thing as 1 cubic centimeter.
Yeah, actually, that's a very important thing to write this
Yeah,
down,
it
guys.
is.
Again. 1 milliliter is equal to 1 centimeter cubed.
Very important.
That means if you had a box that was 1 centimeter. Now, a centimeter, by the way, just from a perspective, is about 1 fingernail width by 1 fingernail width by 1 fingernail width. That's a centimeter. So if you would have a box that was 1 centimeter by 1 centimeter by 1 centimeter, that would be the definition of a milliliter.
1 milliliter.
In fact, while we're at that, do you understand if you were to fill that box with water, not add the mass of the box, it would weigh 1 gram.
Right. That only applies to water because water
Right.
has a density of 1 gram per milliliter.
Yeah, other substances have different densities. And actually, that is the definition of how they.
That's how they came up with the
Came
SI
up with
system.
the SI system.
It's all based on water.
Yes. Yeah. In fact, the temperatures,
Yeah.
Celsius scale.
Celsius scale's based on water.
Actually, it's based upon water and also the meter
Yes.
and what a meter is,
Yep.
which is defined by some things.
Mr. Bergman is making his computer beep.
Yeah. All right. Temperature.
Temp.
We saw the temperature in the
The carmometer.
Thermometer. I love that word.
Isn't it
the
great?
Thermometer.
Yeah.
But we need to talk about the different kinds of temperature. Now, we really don't care much about Fahrenheit, guys. Sorry, scientists don't even use Fahrenheit. So we've got, well, the one you're familiar with is probably degrees Celsius. All right. A couple things about degrees Celsius is at 0 degrees. What's
Water
that?
freezes.
Water freezes. Speaking of
Now,
water.
it's only water. Not everything freezes at 0 degrees Celsius. That is another very common misconception.
That
my
is true.
students
Do you understand that?
come up
Like,
with.
I have, this table right here.
Yeah, it's made out of metal, made out of steel.
It's out of steel, and it's
frozen.
It's frozen.
Yeah.
Frozen? It doesn't feel too cold to
It's
me.
a solid.
But see, frozen means it's a solid.
Right.
All right, but water, we know, freezes at 0 degrees Celsius, and at 100 degrees Celsius, water boils.
Is that 100?
100
Your handwriting's
degrees.
starting to look like mine.
Come
Notice
on.
Mr. Bergman does all the writing. That's because my handwriting is completely illegible.
I wrote it better now.
Yeah.
So 100 degrees Celsius, water boils.
Good.
Okay,
now let's
but
convert.
what we really care about is that there's a conversion between this Celsius and this Kelvin.
Right. The Kelvin temperature,
So degrees Celsius,
Okay, Celsius.
plus
273.
273 equals
The Kelvin.
Kelvin. Notice I didn't write degrees Kelvin.
No,
it's
just Kelvin. So Celsius plus 273 gives us Kelvin. Just remember that 273 number.
All right, so let's do some practice. So
All
let's
right.
say I have, let me see.
25 degrees Celsius.
25 degrees Celsius.
Pretty typical room temperature.
What is that in Kelvin?
Well,
What would I
let's
do?
add 273.
Just add 273. Now do. I don't even need a calculator,
No.
Mr. Sams, on that one. That's too easy.
298.
298 K. All right, let's like take a really cold temperature. Let's say
Okay.
it's negative 150 degrees Celsius, which is really, really cold. That's
Yep.
colder than Earth has ever been.
All right,
Well,
yeah.
the coldest recorded temperature,
Yeah.
at least. We would then, of course, do what?
I add 273.
Add 273. And so we would then add that. We have a
Yep.
negative number, and we're adding 273
Yep,
to
we
it.
get 123.
That'd be 123 Kelvin. Now, what if I
Mr.
were-
Bergman wanted me to use the calculator. I didn't need to use the calculator.
Yeah, I was trying to do it in my head too. All right, what if I have negative 273 degrees Celsius?
Okay.
All right, get the calculator out. I hope you don't.
All
need
right,
one.
all right.
We're going to add 273 to that,
Right?
and you get
0.
0K.
Hey, by the way, we should note that there's no such thing as negative Kelvin.
Yeah, you
it's
can't
an
go-
absolute scale.
And actually, the reason I picked this number, guys,
Yeah.
this is actually a famous temperature.
It's called absolute zero. By the way, there's a test question on your exam. What is the temperature in Kelvin at absolute zero?
0 Kelvin.
Yeah.
You can never. If you get something to 0 Kelvin, what's going to happen?
The universe ceases to exist. No, I don't know.
No, that's not true.
No? Okay.
It stops molecular motion
Yes.
because actually temperature, which I think we've talked about, is actually a measure of the average kinetic energy
Right.
of a molecule. And so molecules are constantly in motion.
Yeah, they're either moving around, or if they're in a solid, they just kind of vibrate.
And so they're kind of vibrating, but when you get it cold enough, they'll stop. And cold enough, the definition of cold enough is absolute zero, 0 Kelvin. Now we probably should go in the other direction. Okay, let's do a couple more understands. Let's say I've got
305.
305 Kelvin. What's that in degrees Celsius? What do
Well,
you do
we
there?
subtract
Yeah,
273.
we subtract 273. And what do you get there?
32
32
degrees Celsius. No naked numbers. Let's try one more.
Well, what about 25 Kelvin?
25 Kelvin. So we subtract 273. So
Big negative
25
number.
minus 273, we get negative 248.
Negative 248 degrees? No, Kelvin.
No, degrees Celsius.
Degrees Celsius.
Yes.
Ah! Negative 248 degrees Celsius. I'm trying
There
to
it is.
remember. Okay, so
All right.
that's how we do temperature stuff. I
That's
guess
it.
we're done.
Yep, enjoy.
Watch that thermometer.